Good morning to all of you. Today we will do a new subject, that is fluid mechanics and hydraulic machines. Fluid mechanics. Right? So this is a part of physics. Clear? The subject is for diploma and degree students. The subject is for BTech third sem students, third and fourth sem, mechanical and civil. Clear? Diploma, mechanical and civil, and electrical also, and double E. Right? The subject is for BTech students, civil mechanical double E, electrical engineering, and for diploma students, both mechanical and civil. And also its fundamental concept is, first chapter is, some chapter also used for plus 2, OJEE, JMN, NEET, etc. Clear? So follow, I will do clearly the theory as well as problems. Right? Now, what is fluid mechanics? This is our subject number 4. First subject, I have already discussed with you, I have already given you class. First subject, mechanics or engineering mechanics. Clear? Second subject, engineering thermodynamics. Thermodynamics. Third subject, mechanics of solid. Mechanics of mass. Now this is fourth subject. Number 4. Fluid mechanics and hydraulic machines. Fluid mechanics and hydraulic machines. Hydraulic machines. That is FMHM. FM and HM. Clear? In shortcut, this is only fluid mechanics. Fluid mechanics is sufficient. Clear? Now I have already started engineering mechanics, engineering thermodynamics, mechanics of solid. Now today I will start fluid mechanics. Right? Now, what is fluid mechanics? Already I have told you what is the mechanics. Mechanics deals with the condition of body at rest or motion. Similarly, fluid mechanics deals with the condition of fluid at rest or motion. Right? Fluid mechanics is defined as fluid mechanics is defined as the branch of science or branch of physics the branch of physics which deals with the condition of fluid The condition of fluid at rest or motion. Clear? This is main three types. This is main following types. Following types. This is fluid mechanics. These three parts. Number one, fluid statics. Number one. Number two, fluid kinematics. Fluid kinematics. Or three, fluid dynamics. Fluid dynamics. Clear? What is the fluid statics? So fluid statics. This deals with the condition of fluid rest. Statics means at rest. Fluid equilibrium of the body. Similarly, fluid statics means fluid at rest. Clear? This deals with the condition of fluid at rest. At rest. Pure equilibrium condition. Clear? This fluid statics. Next. Fluid kinematics. Fluid kinematics. It deals with pure motion of fluid. Clear? Pure motion of fluid. What is pure motion? This means or this means or this deals with the condition of motion of fluid. The condition of motion of fluid without reference to pressure or such agent. Clear? Without reference to any pressure is called fluid kinematic. That is pure motion of the fluid. Next, fluid dynamics or fluid kinetics. Fluid dynamics. What is fluid dynamics? This deals with the condition of motion of fluid with reference to some pressure or such agent. Clear? This is about types of fluid mechanics. This deals with the motion of fluid, condition of motion of fluid with reference to some pressure or such agent. This is about types of fluid mechanics. Now, I will discuss what is a fluid. Clear? Now, this is what is a fluid. A fluid is a substance which offers no resistance to shear deformation. Clear? And it will continue to deform when subject to shear stresses. Only when shear stresses are applied on the body, the fluid can deform. A fluid has no definite shape. Clear? It is no definite shape. And it takes the shape of the container in which it is placed. A shearing force on a fluid will change its shape. But hence, when shearing force acts on a body, on a fluid, it will flow. Clear? The shear stress can be changed its shape. So, when the shearing force acts on the body, the fluid can flow. But when the fluid at rest, since its shape does not change, in that case, the shear stress is totally absent. Clear? Only when shearing force acting on a fluid, it can change its shape. But when the fluid is at rest, since its shape does not change, its shearing force, shear stress is totally absent. Right? Next, what is the properties of fluid? Properties of fluid. Clear? First, what is the fluid mechanics? Three types of fluid mechanics: fluid statics, fluid kinematics, fluid dynamics. Now, what is the fluid? I will discuss what is fluid. Then, what are the properties of fluid? Clear? Number one, density, rho. Clear? Or specific mass. It is the ratio of mass of the fluid to its unit volume, that is rho is equal to m by v. What is unit? Kg per meter cube, where m is equal to mass of fluid in kg, right? V is equal to volume of fluid. What is unit? Meter cube. Clear? So for water at 4 degrees centigrade and mean sea level and mean sea level that is 760 mm of Hg. What is raw water is equal to? 1000 kg per meter cube. Right? In fluid mechanics, the water is taken as standard fluid. For gases, air is taken as standard fluid. Clear? In thermodynamics, we are using gas. Here, we are studying only fluid, means water. Clear? For fluid mechanics, the water is the standard fluid. Its rho is equal to density is equal to 1000 kg per meter cube at 4 degrees centigrade and mean sea level, that is 760 mm of Hg. Now, number 2, this is fluid property number 1. Number 2, specific weight. W, small w, weight per unit volume. The specific weight of fluid is defined as the weight of the fluid per unit volume. That is specific weight W is equal to W/V, Newton per meter cube. Clear? Where W is equal to weight, Newton, V is equal to volume of fluid, meter cube. Clear? So W is equal to m into g, mass into weight. Mass to excel due to gravity. What is mass unit? What is unit of mass? Kg. G is equal to meter per second square. So what is this? Kg meter per second square Newton. Clear? Weight is equal to kg into meter per second square is equal to Newton. So what W is equal to W/V m into G/V. Clear? What is m by v into g? This is rho. So what is it? W is equal to rho into g. This unit also Newton for water. What double water is equal to rho water into g. For rho water 1000 into 9.81. Clear? This is equal to 9810 Newton per meter cube. So double water is equal to 9810. So 9.0 kilonewton per cube. This is excessive weight of fluid or water. This is water. Next, specific gravity. Specific gravity. Yes. Clear? The specific gravity of liquid. The specific gravity of a liquid is defined as the ratio of the specific weight of the liquid to the specific weight of water. Clear? Specific weight of water. Now, therefore, as liquid is equal to W liquid by double water. Clear? So for any substance, the specific gravity is equal to the specific weight of that substance to the specific weight of water. Standard substance. Standard substance means for liquid, for fluid mechanics, the standard fluid is water. For gas, this is air. Clear? This is fluid mechanics. So S liquid is equal to double liquid by double water. Or for kerosene, S kerosene is equal to S oil is equal to double oil by double water. Clear? For any liquid, specific weight of liquid by specific water. This can also written as rho liquid into G by rho water into G. right? G is cancel out. So what is S liquid is equal to? Rho liquid by rho water. Clear? This is specific gravity of a liquid, or S oil is equal to, or S oil is equal to rho oil by rho water. Clear? For water, S1. For mercury, what is S H is equal to 30.6. Clear? So, suppose for mercury, what is S H is equal to rho G by rho water. Clear? This is 30.6 is equal to rho G by 1000 kg per meter cube. What is rho G is equal to 1000 into 30.6 kg per meter cube. Clear? So what is rho H is equal to 13600 kg per cube. Similarly, double H. Similarly, this is for density. For specific weight, for specific weight, this is for density. What is S H is equal to double H by double water. Clear? So, 13.6 is equal to double H by 1910 Newton per meter cube. So double H is equal to 30.6 into 9810 Newton per meter cube. Right? So 30.6 into 9.810 kilonewton per meter cube. This is for says weight. This is for mercury. Clear? Next, says volume. Specific volume. Pro, BS. Volume per unit mass. Excessive volume of fluid may be defined as the volume of the fluid per unit mass. Per unit mass. That is BS is equal to B by M. What is B? Volume meter cube per kg. Where B is equal to volume in meter cube. M mass in kg. Clear? Next, viscosity. Viscosity of fluid. Suppose a fluid contained with two plates, two parallel plates. Clear? Consider two parallel plates A, B and C, D. This is A, B, C, D. This is contents of fluid. The distance in two plates is Y. Y. A force, shear force acting on the upper plate. Clear? And the upper plate moves with the velocity v. Right? This plate is fixed. A, B, C, D. The upper plate moves with velocity v. Clear? This force F is directly proportional to area of the plate. Right? Directly proportional to the velocity with which upper plate moves. And inversely proportional to the distance between two plates. Clear? This area A, what is the area A? What distance Y? What is the force F? Clear? Consider a fluid contained between two parallel plates. Two parallel plates. That is AB and CD. That is AB and CD. Clear? AB is fixed. A force affecting on the upper plate CD. As a result of this force, the upper plate moves with velocity v. Clear? Let F is equal to force acting on the upper plate. A is equal to area of each plate. Clear? Y is equal to distance between two plates. Clear? B is the velocity. B is the velocity with which the upper plate moves. The upper plate moves. Clear? Now, the upper plate F now, so what is viscosity? I already describe what is viscosity, but what is definition of viscosity? The viscosity of a fluid is a measure of the resistance of the fluid to shear or angular deformation. Clear? The viscosity of fluid is a measure of the resistance of the fluid to its shear or angular deformation. Now, consider a fluid particle between two parallel plates. Between two parallel plates, AB and CD. Clear? A is each of area of each plate. Y distance between two plates. Between two plates, so fluid is flowing. Clear? It contains of fluid. F is equal to force acting on the upper plate. As a result of this force, the plate moves velocity v. Clear? This is lower plate, this is upper plate. So, this is lower plate AB, this is upper plate CD. The upper plate moves with velocity v. Clear? So what is F? Shear force. The shear force is directly proportional to area of each plate. Clear? The shear force is the shear force F is or depends upon the following. Clear? Number one, directly proportional to area of each plate, that is F is proportional to A. Question 1. Clear? Now 2, directly proportional to its velocity, that is F is proportional to B. Equation 2. Clear? Number 3, inversely proportional to area, that is F is to distance between two plates, that is F is proportional to 1 by y. This is question 3. Now combine equation 1, 2 and 3. Clear? Combining equation 1, 2 and 3. Clear? What is F is equal to? F is proportional to A B by y. Clear? This implies F is equal to mu A B by y. What is mu is equal to? Dynamic viscosity or simply viscosity of fluid. Viscosity of fluid. Clear? So what is unit of mu? What is the stress? This is shear force. What is shear stress? Shear stress. Tau is equal to F by A. What is F? Mu A B by y by A. Clear? So tau is equal to mu B by y. This is shear stress. What is unit of shear force? Newton. What is unit of shear stress? Newton per meter square. Force area. Clear? Newton per meter square. So first find out what is unit of mu. Unit of mu. Unit of mu. What is F is equal to? Mu A B by y. This implies what is mu is equal to? F y by A into B. What is F? Newton meter by meter square into meter by second. Clear? Newton meter by meter square meter per second. Clear? Cancels. Newton second per meter square. So what is Newton mu is equal to? Newton second per meter square. Which SI unit? SI unit. CGS unit. CGS unit. What is mu is equal to? Dyne second by same square. Clear? Means 1 poise. 1 poise. So 1 dyne second by same square means 1 poise. Clear? So 1 Newton second per meter square. Now 1 Newton second per meter square is equal to 25 dyne. Clear? Into second by 10 to 4 same square. 10 to 4 cancels out. Clear? This is equal to 10 dyne second per same square means 10 poise. Clear? So 1 Newton second per meter square is equal to 10 poise. Right? This is about viscosity of fluid. So 1 Newton second per meter square to 10 dyne second square is equal to 10 poise. Clear? Next, kinematic viscosity. Next, kinematic viscosity nu. Kinematic viscosity nu. Clear? It is the ratio of the kinematic viscosity defined as the kinematic viscosity of a fluid is defined as ratio of the viscosity of the fluid, viscosity of the fluid to its density, to its density. Clear? What is nu is equal to? Therefore, nu is equal to mu by rho. Clear? That means nu is equal to kinematic viscosity Kinematic viscosity is equal to mu viscosity by density. Right? So what is unit of nu? So mu by rho. What is mu? Newton second per meter square by kg per meter cube. Clear? Per Newton. Per Newton. 1 Newton is equal to 1 kg into 1 meter per second square. Put value of Newton here. Is equal to mu by rho Newton kg meter per second square into second by meter square into meter cube by kg. Right? Kg gets cancels. Second cancels. Meter square cancels 2. So finally, meter square by second. Clear? Meter square per second. This is 10 to 4 strokes. So 1 meter square per second is equal to 10 to 4 strokes is equal to 10 to 6 centistrokes. Clear? 1 meter square per second is equal to 10 to 4 strokes. That means 10 to 6 centistrokes. This unit of kinematic viscosity. So what is shear stress? Tau. Tau is equal to force by area. Clear? Mu A y by A I have already given. So tau is equal to mu B by y Newton per meter square. This is shear stress. Torque. Torque. F into radius. What torque? Shear force into radius. What is shear force? This shear stress formula. What is shear force? Mu A B by y area radius d by 2. Clear? This is torque. What unit? Newton meter. Force and radius. Shear force Newton, radius meter. This is Newton per meter square. Clear? Today I have already discussed some formula. Next class I will do some problems regarding this formula. Clear? This is our first class fluid mechanics. Clear? Very important subject for civil and mechanical students. And also this is useful for plus 2 students those are appearing JEE Main NEET examination. Clear? Thank you. Make like, share, subscribe for this my channel. Thank you.